Alright, this is the breadboard. The breadboard is what we use to build the circuits on. Underneath, there are a bunch of connections that connect the different components. And we see here we've got power rails, several of them going across, and one on top. The power rails are connected along the lengthway all the way from the top to the bottom. So this red strip is connected all the way through. So if I plug in, so on the power rail, if I make a connection here, another connection here, the orange and the red wire are connected, and if I plug in the yellow wire up here, it is also connected to everything. And then the blue, again, is its own strip. So if I plug in the yellow here, it is not connected to the red or orange wires. Then on the rest of the breadboard, we have connections that go across in rows. So at the top, you'll see A, B, C, D, and E. Those 5 are connected to each other. Then we have a gap, and then we see F, G, H, I, and J. Those 5 are connected to each other. And then we've got a bunch of those rows going down, starting through 1, 2, 3, 4, 5. None of the rows are connected to each other. So we've got, let's say we've got row 15 here, and then row 16 here. Row 15 and 16 are not connected. So the red wire does not connect to the orange wire. But then at the end of row 15, we've got that yellow wire plugged in. The red wire and the yellow wire are connected. Alright, so here we have the first simple circuit that we will construct on the breadboard. The first step will be to set up the power supply. Alright, so at the power supply, first we want to make sure that we have nothing connected so we don't accidentally make a short circuit or anything when we turn it on. So now we turn on the power supply. For the circuit that we're building now, it's asking for 12 volts. So let's turn the output on so we can select which output we use. So we've got 6 volts plus 25 minus 25. So since we need 12 volts, we need to select the 25 volt source, and then we'll arrow over to the ones digit, and we can spin this knob until we reach 12 volts. So now, coming out of the 25 volt supply, we've got 12 volts because we've set it to 12 volts. At this point, we'll turn off the output so that we can build the circuit. Alright, the circuit calls for a 1K resistor in series with a 2K resistor. So first we'll grab the 1K resistor, which is brown, red, black, and we'll plug it into one of the rows. And then the next resistor is the 2K resistor, which is red, black, red, and we'll plug that into the same row as the 1K resistor. So now the 1K and the 2K are connected at this point here. Now we can make our power supply connection. So I'll plug the 2 cables into the power supply. And the lab shows me that we're connecting the plus 12 volts to the 1K resistor and minus 12 volts to the 2K resistor. At this point, we can go ahead and turn our output back on the power supply. So we'll hit the output on button. And so now we have power flowing through our circuit. So now what we need to do is keep following the lab and take our measurements. The first thing the lab says is to measure the current flowing through the circuit. So for this, we have to follow our current measuring rules. When you measure current, you always want to measure in series. When the multimeter is set in current measuring mode, it has essentially 0 internal resistance, which means it acts just as a wire. So to measure in series, what I'm going to do is I'm going to break open the circuit. So I'll remove the wire there. I'll take my multimeter, set it to current measuring mode. And then because the multimeter in current measuring mode just acts like a wire, what I'm going to do is use the 2 leads from the multimeter to complete the circuit where I broke it open. So before I had this red clip here, what I'm going to do is I'm going to connect the red lead from the multimeter there, and then the black lead from the multimeter, I will use that to complete the circuit by touching the resistor. And now if we look at the multimeter, we'll see, and here we're getting a reading of 3.9 amps, or 3.9 milliamps, which makes sense. We've got 12 volts divided by 3 kiloohms, which would give us 4 milliamps, and there are always slight discrepancies, so this number is right on the money. Okay, so now we're measuring voltage. Before we were measuring current over here, now we need to move the dial to voltage. This circuit uses 12 volts, and you always want this number to be as close but higher than the voltage that you're measuring. So we've got a 2 volt option, which is less than what we're measuring. The next option is 20 volts, so that's what we want to set it to measure this 12 volt circuit. When we measure voltage, we always want to measure that in parallel. When the multimeter is in voltage measuring mode, it has essentially infinite internal resistance, which means that no current will flow through it. So if we want to measure the voltage across the 1K resistor, we'll put 1 lead of the multimeter on each side. We will put the red lead on the plus side and the black lead on the negative side. And if we look at the reading on the multimeter now, we'll see 4 volts. And that measurement makes sense, because we formed a simple voltage divider here. We have 12 volts flowing through 3 kiloohms, and we've got it divided by 1 kiloohms and 2 kiloohms. So we've got 1/3 of the voltage across the 1 kiloohm resistor and 2/3 of the voltage across the 2 kiloohm resistor. Okay, so in this circuit, we've got some components in parallel and some components in series. When you've got resistors in parallel, you've got a current that goes through each resistor, but it's a different current going through each resistor. So at the point where the 2 resistors come together, you've got 1 current coming into there, but then at this point it splits, and some of it goes through this resistor, and some of the current goes through this resistor. So now we'll show how to measure that current, and we'll see if those current measurements make sense. Alright, so we've got a current coming in from the source, which goes to a 510 ohm resistor, which is green, brown, brown, and then it splits with that one with the 1K resistor, which is brown, black, red. And then those 2 ends come back together, so we'll hop across the gap in the middle of the breadboard and connect them back up. And so we'll see that the resistors are connected here and they're connected here, but there is no connection going through the middle. Next, from this point, the current splits between 2 2K resistors, which are red, black, red. So I'll plug that in there. There's 1 2K resistor, here's another 2K resistor, and then those 2 ends come back together, so we'll plug those back into the same row at the bottom. And we always want to make sure that the wires aren't making stray connections, because we don't want to change the circuit inadvertently. And then down there at the bottom where we connected the 2 2K resistors, we'll plug in another wire to connect our ground. So we're using the same 12 volt that we had set up from the previous circuit, so I'll go ahead and just plug that up. Now remember, before you connect the circuit, you want to have your output off, that way you don't accidentally make any short circuits. So I've made the connection, and now I'll hit the output on button again on the power supply. Now the power supply is on, and we have current flowing through our circuit. So now we're going to measure the current flowing into the circuit. So remember, when we do that, we need to measure the current in series. So I've got my multimeter set to current measuring mode. And now we'll break open the circuit where the power supply connects to the circuit. I'll remove that red lead, and I'll clip my multimeter to it, and then I will complete the circuit with the other end of the multimeter. And then if we look at the multimeter now, we see 8.9 milliamps. So we've got 8.9 milliamps flowing through the whole circuit. Now up here, we've got a voltage divider, current divider going between these two resistors. So let's see how much current we have going to each of those resistors. So now I've connected the power supply back to the red cable, and now we'll break open the circuit at the 1K resistor. So let's pull that out of the circuit, open it up. I'll connect the red lead to positive again, and the black lead to where that 1K resistor was just pulled open. And if we look at the multimeter, we'll see that we now have 3 milliamps flowing through that resistor. So let's close that circuit back up and measure the current flowing through the 510 ohm resistor. So we'll break the circuit open at that point. I'll connect the red lead from the multimeter back to the positive end of the power supply, and I will complete the circuit with the black lead of the multimeter. And if we look at the multimeter, we'll see that we have 5.9 milliamps running through this branch of the circuit. Now if we remember, we had 8.9 milliamps to begin with going into the circuit. Then we came to this current divider, and we had 3 milliamps going through the 1K resistor and 5.9 milliamps going through the 510 ohm resistor. 5.9 plus 3 equals the 8.9 that we have going through the circuit. And the 3 milliamps going through this and the 5.9 flowing through that makes sense, because this value is twice as much as this, so together we have 1500 ohms. And this value has 2/3 of the resistance, this value has 1/3 of the resistance. Current takes the path of least resistance, so we have more current flowing through this branch. So we'll have 2/3 of the current going through this branch because this has 1/3 of the resistance. We have 1/3 of the current going through this branch because it has 2/3 of the resistance.